Okay, guys, today we're going to look at 2.6, and 2.6 is compounds. Um, this is from yesterday right here. Some types of matter are elements, which are pure substances, and they can't be broken down into simpler substances. Okay, and we know that everything is composed of matter. And from yesterday, if you recall, there's a total of 92 different elements or pure substances that occur in nature, and they compose all the matter in the universe. Now, I know if you've looked at my periodic table of elements, there's more than 92 listed, and that's because those other ones have been created in a laboratory setting. Okay, down here, many other types of matter aren't made of just elements, they're actually made of compounds. And what exactly is a compound? Well, a compound right here, it's a substance that forms when two or more elements combine chemically. All right, so carbon is an element, oxygen's an element, and when you put one carbon right there and two oxygens, you get carbon dioxide, CO2. All right, and they're chemically combined, and just like water is H2O, that's two hydrogen atoms and one oxygen. All right, I want to play this little video for you, so maybe you can sit back and watch this. Here we go.
This is the all-new Nutrisystem with a personal weight loss plan that adapts to your...
All right, so much for that.
What is a chemical compound? Let us learn what a chemical compound really is. Click on the titles listed here. Atoms, molecules, elements, and compounds. When two or more elements bond together chemically, they form a new substance with its own properties. This combination of elements is called a compound. Water is a compound made of hydrogen and oxygen. Carbon dioxide, which is what you release when you exhale, is a compound made of carbon and oxygen. Most substances around you are compounds or mixtures of compounds. All compounds are made up of molecules. A molecule is the smallest part of the compound that has all the properties of that compound. For example, a molecule of water is made up of two atoms of hydrogen and one atom of oxygen. Let's compare compounds and mixtures. Combining elements to form a compound is different from just mixing elements together. In a mixture of iron filings and sulfur, for example, each element holds on to its original properties. You can separate the mixture easily by dragging a magnet through it, attracting all the iron filings. But if you heat the mixture, a chemical reaction takes place that bonds the elements together. Not only does the new compound look different, but it also has no magnetic properties. Thus, compounds do not possess the properties of the elements which they are composed of. Separating the chemical compounds. Unlike mixtures, which are fairly easy to separate, the strong bonds in a compound can be broken only by chemical means. By using electricity, we can break the bonds holding the elements hydrogen and oxygen present in the compound water. When an electric current passes through two tubes full of water, it breaks the tight bonds between the hydrogen and oxygen atoms in each water molecule. Oxygen atoms bubble up to fill the blue balloon, while hydrogen atoms fill up the red balloon. There are two hydrogen atoms for every atom of oxygen in a water molecule H2O. Therefore, the red balloon fills up faster. Thus, when water is electrolyzed, oxygen gas is formed at the anode, while hydrogen gas is formed at the cathode. Energy changes take place when chemical compounds are broken down. just a difference of one atom. The compounds displayed here may not look alike, but they are made of the same elements, iron and chlorine. The only difference between them is one atom. Ferrous chloride, FeCl2, has one atom of chlorine lesser than ferric chloride, FeCl3. The proportions of the elements present in a compound must remain constant, or else the compound changes into something else.
Pepsi is made for football.
All right, so it took me a while to negotiate through that. So as you can see down below here, they told you a compound's made up of 2 or more elements, but the number of atoms of each element in that compound can change it dramatically. Okay, so here are 2 things that are true of all compounds. A compound always has the same elements in the same proportions. What they mean by that is carbon dioxide always has 2 atoms of oxygen and 1 atom of carbon, while water always has 2 atoms of hydrogen and 1 atom of oxygen. A compound always has the same composition throughout. For example, all the carbon dioxide in the atmosphere and all the water in the oceans have the same proportion of elements. All right, properties of compounds. The properties of compounds are different from the properties of the elements that form them. Sometimes they're dramatically different. Here's an example. We know that salt, sodium chloride, is made of, there we go, sodium chloride, common table salt. However, the individual elements, when they're by themselves, just an element, they're dramatically different. Here's an example. So common table salt is sodium chloride. It contains sodium and chlorine. Sodium is a solid. In the element form, it's a solid, and it's very explosive. It reacts explosively with water. Chlorine is a poisonous gas. However, when you put 1 atom of sodium with 1 atom of chlorine, you create this harmless, unreactive compound that you can safely eat, which is sodium chloride. So very interesting and sort of counterintuitive. Now they give you the structure of compounds. Compounds, like sodium chloride, form structures called crystals. And what a crystal is, it's just a rigid framework of many ions locked together in repeating patterns. Okay? Ions are electrically charged forms of atoms. We'll come back to all this. Don't worry. This is like a kind of a niche introduction. Okay, so some structure of some compounds are in a crystalline form. Other compounds, such as carbon dioxide and water, form molecules instead of crystals. A molecule is the smallest particle of, a molecule right here. That didn't work. A molecule is the smallest particle of a compound that still has the compound's properties. All right, so in summary, a compound is a unique substance that forms when two or more elements combine chemically. A compound always has the same elements in the same proportions, meaning water is always H2O. Carbon dioxide is always CO2. The properties of compounds may be very different from the properties of the elements that form them. Example above, sodium reacts explosively with water. Chlorine is a poisonous gas. However, when you combine one atom of sodium and one atom of chlorine, you get a harmless substance that we put on our French fries, which is sodium chloride or table salt. Some compounds form rigid frameworks called crystals, while others form individual molecules. A molecule is the smallest particle of a compound that still has those compounds' properties. Okay, I would now like you to do the practice. I wish you luck, and we will discuss the this when we're done. So please complete the practice. Mark this video done on Google Classroom, and then you want to go in and complete this assignment 2.6.